Explorers, and welcome to another video. Today we are going to talk about Docker, and we're going to go through the basics of creating a Docker container. So let's switch over to my screen here, and you see this little directory here. This is a Docker container that I have set up, or at least the configuration for one. And this is a Docker container that will run the Moonin service. And this is some statistics service that checks how much disk usage you have, how much GPU you have, and so on, how much of the system is used. And you can add much more information if you want. And it's really good when you have an environment with a lot of servers and need to keep track on how the actual health status of all those services are. You need something like this in order to keep track of everything, because it can be a lot of information. So Moonin, I'm not going to talk more about that. I have a specific video about that, but I'm going to talk about the Dockerization of it. And here you see this directory, and the only file that is really interesting for Docker is this Docker file. So let's look at that specific file. And a Docker container is pretty much, you start from some state. You can create your own Docker base line image if you want, and I have a video about that as well. But this is how you actually configure and set up a Docker image. First off, you need something to start from. In this case, I'm gonna run this on a Raspberry Pi, so I want to build it into an ARM environment, and I want to use a Debian image, and I want to use the Buster version of it. So this first part here is actually just a specific branch on GitHub, on Docker Hub, that is specific for this Debian. So this is the, you say, contributor name and then Debian. So if I were to release something here, I would probably write kalaspuffar / Docker Moonin, which is actually something that is available on Docker Hub, which is this specific package. But if you just want to use Debian, which is a general package that everybody is using, you don't need to write Debian, you just write Debian and then Buster. So this is a start image. You start from some state. And this will download that specific image and create a snapshot locally for you when you are building. Then I want to run a couple of things just to upgrade and put everything in a good state. So I do an update here, I run a command, update, and then I set an argument here. And this argument is something that will be set inside of this runner and be added to the actual build flow. Another thing you could do is set environment variables as well. But here I set the argument of Debian front end. So if I run some script that looks for Debian front end as an input argument, this will be set there. So non-interactive is what I want to install all these packages. Not sure that this is required, but this was something that I found that could be a good addition when you're running Apache. So then I do a full upgrade. I run the install of Apache, Moonin, and Moonin node. Moonin node is what's gathering the statistics. Moonin is the server that is actually running locally and fetches the information from the different nodes. And then I have Apache, so I can actually show the different metrics. And I clean up my OPT directory so I don't have any extra. This will make the image a bit smaller. So every time that you can do a cleanup, so the end image will be smaller, it's a good thing to do. Next up, I add a couple of files here, a bunch of different configuration files for Moonin, Apache, and so on. And these files you saw in the specific directory. So this is something that is local to my machine, and I add them into the Docker image. So it's a move or copy into the image part of this Docker image. So I need to put them in there from the outside. And I can choose where I want to put them in this specific Docker image. And a Docker image is just an environment. In this case, it's a Debian environment, but it could be whatever you want to put in there. As you see, this is an ARM processor thing that I build, but I'm not running on an ARM device, so I emulate something that I can actually put these things in. I don't even think I can run this Docker image locally, but I can build it into an ARM device. So this could be whatever. You can have a Slackware, or you can have another Linux kind environment. I don't know if Microsoft have actually built an image you can run, let's say, Windows in a Docker environment, but perhaps you can run a Mac OS in a Docker environment. I don't know. But there is a bunch of different images. And then I set this, run another command to set the start sh, so it's runnable. I set a bunch of environment variables, so I know which user and group should be running on Apache and where the log should be saved. Then I want to expose. So for this image, I say that the actual port 80 is something that I want to use. So I will expose it so it's available from this Docker image. If you have it in a Kubernetes cloud, that doesn't mean that it's exposed to the world, just exposed from the current pod or the current Docker instance that it's running. If I run it locally, I still need to map and say I want this local port to be mapped to this port inside of this Docker image. But if I haven't had this here, you could not reach this Apache install here because it's not exposed, so it's closed. And then you have this cmd command here. It's what I want to run when I start a Docker image. So everything up here is run during the build process, but this last command here will not be run. It's just something that will run when I start the actual Docker image, either in the cloud or locally on my machine. So I put a bunch of things in the start command so I can actually have some stuff running. The same goes for entry point. It's a different way to say that I want to run something when this Docker image starts. So this is pretty much the basic of Docker. You just start from a start point, do a bunch of commands in order to create a state that you want to run later on. So let's jump out here and look at my start script so you get a little feel for that. So this is a bin bash script. It will restart the services Munin node and cron. Cron is because the actual Munin servers will fetch things through a cron command from the different nodes. So you need to run cron. Then I wanted to create this Munin run directory. It's not really required, but when I ran it locally, I had to put these in order to actually start the service later on. But when you're running it in the cloud, these things might be mounted already. For instance, if you say that you have a Kubernetes cloud, you could actually configure and say that this should be available already. And then I run the specific command munin and then shell. So I go over to the munin user. I go over to the munin user and then I run shell bin bash and I want to run munin cron. So as the munin user, I want to run munin cron. And the reason I want to run this is because the cron job is set on a schedule to run not so often. I think it's every 10 minutes or so. And I wanted to have an instant result in my database when I start this up. So I wanted to have, now I want to see immediate state, and then you can run this gathering script more times whenever the cron job gets around to it. And then I want to start my Apache in the foreground. So Apache will be the actual thing that is holding this Docker image running. So you need something when you start a Docker image that will keep it in a running state. Because when this command is stopped and not running anymore, it will shut down the actual image as well. So you need something that is running. So that's what I'm adding to this script here. And that's pretty much it. And if I want to build this, let's go up here. We have a script for that. I've done a bunch of things here. So here we have a build script, for instance. So I run docker build. This specific directory, I want to tag it with a specific tag. In this case, I want to push it to Docker Hub. So I will give it my username so that I have already logged into Docker Hub with. And then the project name on Docker Hub, and then the actual version number in this case. But this is just a tag. It could be whatever. You could say Debian here if you want. It's just a string to tag it up so you can find it later. So if I run the build here, it goes really fast because I've already run. So all these states are already cached. But you see here that it fetches this Buster image up here, and then runs all the different commands and caches the results after each one of them. If we again go up here and take the next command here, we have docker push and then the specific tag. This will push it up to Docker Hub. So I will have that specific image available on Docker Hub. So if we go over there, we can see that specific image. So here we see this specific image, Kalas Buffer, Muni Docker Hub, and under tags here I can see that I have this version 1.11 and it was pushed recently. And I have some tag that I called latest, and it is not the latest one. I pushed that 6 days ago. So this is another tag. And you see here I've patched a lot of different versions here. I even have a version 2 around here somewhere. Yeah, there I pushed a version 2. I tried to run this with Buster as well. Didn't get that to work. But this is how you do this and get your Docker images up to Docker Hub as well. So this was what I wanted to cover today. I hope that you found this interesting. I hope that you learned something today. If you have any questions or suggestions, leave them down in the comment section down below. If you like this video, give it a like, share it with your friends and colleagues. If you haven't subscribed yet, please do that. And I really hope to see you in the next video.